One of the major skills that you should learn in studying organic chemistry is being able to identify a family name or the organic family of a given structure. So if you're given a structure, you can identify the family that it belongs to, or given the name of a molecule, you can identify which family it belongs to. I think this is a skill that seems like it would be learned through studying organic chemistry, but I think because of all the information you get in organic chemistry and how big those textbooks are, I think we sometimes miss some of the important things where we're focusing too much on some of the details that are important, but they don't take you as far in understanding organic chemistry and biochemistry as understanding the family names in the family. So being able to do that, I think, is a high priority, or should be a high priority, in organic chemistry teaching and organic chemistry learning. And so this video is going to help us to do that and make sure we can do it. It's not a difficult skill, but it does take a little bit of work, and you'll have to do a little bit of memorization. But with that, the amazing amount of things that you can do with this information, having this skill, is immense, and it can really track a long way through deeper studies and into living systems that you might learn in biochemistry or physiology or genetics. And so I want to make sure that I want to, at least in this video, try to get some of that information and details across to you so that you can be better equipped going forward in your career and understanding of chemistry. In this video, we're going to study 12 organic chemistry families. And I know there's more, but these are kind of the central 12, I think, that most textbooks would hit on and cover. So I won't go into some of the more obscure ones. They're not really obscure, but you don't see them as often. And this is really leaning towards the ones you'll need if you went further into the life sciences. If you're going to be a hardcore organic chemist, this might not be detailed enough for you. But if you're going into the life sciences or more interested in the life science of organic chemistry, this might be better. And the reason we want to be able to do this, as I was getting to, is that there are hundreds of thousands of organic molecules out there. I mean, hundreds of thousands. And so to understand the reactions that each of them can undergo, the properties that they have, the functions that they harbor, is very difficult if you have hundreds of thousands of different ones. So a way to simplify that is if you can take a molecule and categorize it into one of these 12 families. Each family has a very specific set of reactions that they undergo. Their properties are all very similar. Their functions are all very similar. So by understanding 12 families, you really understand hundreds of thousands of molecules. So it's a very powerful thing to be able to do. And so let's do that, and we'll start by first just identifying the 12 families. Now these are the 12 organic families that we'll talk about. At this point, I just want to mention that if you've not studied these at all, and you've not had an organic chemistry course, this video probably is going to not make much sense to you. This is more for those who've been through organic chemistry. Most people who study this would probably study it over a semester period of time, studying each of these individually. And so this video tries to bring all that together and try to organize our thoughts a little bit so it doesn't seem so scattered from what a semester could do to our brains. Let's just try to reorganize all this now that we've learned a little bit about it. So these are the 12, alkanes, alkenes, alkynes, aromatics, alcohols, ethers, amines, aldehydes, ketones, carboxylic acids, esters, and amides. And I've organized them in these two columns because what I know is that the ones in the left-hand column, or the right-hand column, these guys all have a carbonyl group somewhere in them. A carbonyl group is anywhere where you see a carbon double bonded to an oxygen. So if you see a carbonyl group in a structure, or you're trying to draw an amide, an ester, a carboxylic acid, and so forth, you're going to need a carbonyl group in there. The left-hand column, none of them have carbonyl groups, so I sort of separate them in my head a little bit that way, just to kind of minimize the number of things I need to memorize. So let's start with the left-hand column first, and then I'll come back to the right-hand column. So I'll start at the bottom. Amines definitely must have a nitrogen in them. And nitrogens like to make 3 bonds. So I draw a nitrogen with 3 bonds to it. We're in the non-carbonyl side of the list, so there's no carbonyl group in here. But attached to each of these bonds to nitrogen are either an R group or a hydrogen, and that's the same on all of them. Okay, no carbonyl group. And what I mean by R group, that's sort of a general term for sort of like an alkane of any kind, basically. And so that's what you're looking for there. But you're looking for that nitrogen is what you're looking for. So if you see a nitrogen and there's no carbonyl group, you're probably dealing with an amine. An ether is an oxygen-containing molecule. An ether basically has an R group or some carbon chain, another way to think about an R group, connected to an oxygen, connected to another R group, and I put the prime on the second R group to indicate the 2 R groups don't have to be, they could be the same, but they don't have to be the same. So you're looking at a carbon chain bonded to an oxygen, and that same oxygen is bonded to another carbon chain. An alcohol is very similar to an ether, but instead of being bound to a second R group, it's bound to a hydrogen. And so an alcohol has this OH hanging on a carbon chain of some kind. An aromatic, I'm going to put it way over here. An aromatic is a ring structure, and a very specific ring structure, where it's basically any molecule containing that benzene ring. And don't forget that aromatic ring there is also written sometimes as that, and is also written sometimes, see if I can do it, sometimes my pen here doesn't allow me to draw really small things, but you may have seen this before. So all 3 of those ring structures I just drew are the same thing. There's nothing different about them. Just some internet sources, books use one versus the other, but they are representing the exact same thing. So if you see one of those guys in a structure, you're dealing with an aromatic. So aromatics are usually pretty easy to spot because not too many of these other ones have too many ring structures in them typically. Alkynes is where you'll see a triple bond between 2 carbons. So if you see a triple bond between 2 carbons, you're dealing with an alkyne. An alkene is where you're dealing with a double bond between 2 carbons, and then attached to those 2 double bonded carbons, or even the triple bonded carbons in the alkynes, what's left where I just didn't put anything, these can be any R groups basically. I can put R groups on there. Typically they're not shown that way, but you'll have different R groups hanging on each side of that carbon triple bond. It could be a hydrogen as well, so it doesn't have to be an R group. But it's basically, as long as if you see that carbon triple bond carbon, you're dealing with an alkyne. If you see a carbon double bonded carbon, you're dealing with an alkene. I'm not going to go into too much detail, but this structure right here, it looks like there's some carbon-carbon double bonds like right there. That's not really a carbon-carbon double bond because this structure down here is more representative of an aromatic, where it's actually not a double bond, but it's really like a bond and a half. So don't get confused. If you see these, what looks like 3 double bonds in a 6-carbon ring structure, as we have right here, that's an aromatic. Other than that, you're dealing with an alkene when you see a carbon-carbon double bond. An alkane is basically molecules that have carbons and hydrogens, and the carbons, every carbon is single bonded to another carbon. There's no carbon-carbon double bonds, there's no carbon-carbon triple bonds. So alkanes, alkenes, and alkynes are very similar in structures and in properties and in reactions, as you'll soon find out, but they are a little bit different in the way, in the terms of the number of bonds between carbon atoms. And in alkenes and alkynes, not every carbon-carbon bond must have a double or triple bond, but if one of them does, then it falls into those categories. So let's look at a couple of examples of these, just so we can kind of use our knowledge of this and you can kind of see it in real action. So here's a first example, and what I want you to do is just pause the video and determine what the family of this is. And then when you think you've got it, come back to it and I'll talk about the mental process of thinking about it. Okay, so in this one I noticed a couple of things. One is, notice the carbons are all single bonded to each other. So it looks a little bit like an alkane in that way, but I notice as well there's this oxygen sitting in there and a hydrogen sitting in there. And so therefore, when I'm looking at this, I see this oxygen and this hydrogen, and so that tells me it's not an alkane, because an alkane would not have an oxygen in it. So alkanes must have only carbons and hydrogens, alkenes have only carbons and hydrogens, and alkynes have only carbons and hydrogens. So it's not one of those. I also know it's not an alkene or alkyne because there's no carbon-carbon double bond or carbon-carbon triple bond. So what it looks like here is I have an O bonded to an H, and then what's hanging on the O is this big thing, that big group, and that kind of looks like an alkane or a carbon chain of some kind. And so a carbon chain of some kind we can designate as an R. So this is RO, this has the typical ROH structure, and so this falls under our alcohol. Here's a second example. Again, pause it so you can give it a try first, and then come back to the video, and I will give you the mental breakdown of it. So in 2, notice I just see carbons and hydrogens. So that I only see carbons and hydrogens, it rules out an alcohol, because an alcohol must have an oxygen in it, as we just saw in the previous example. An ether must have an oxygen in it, and an amine must have a nitrogen in it, so it can't be one of those 3. I also notice something very important, and I see right here we have a carbon-carbon double bond. The rest of the atoms are all carbons and hydrogens, so this is very indicative of an alkane. Notice I have things hanging off each side of the carbon that are just carbons and hydrogens, and so this has the carbon-carbon double bond, and so this is an alkene. Had it been a triple bond between those two, it would have been an alkyne, and if it had just if that was a single bond between those two carbons I circled, then this would have been an alkane. So alkanes, alkenes, and alkynes, very similar in structure. One just has no double bonds or triple bonds, one has double bond, and one has a triple bond in it. So here's the next example. Pause it for now, and then come back and we'll talk about it. So in this structure, I definitely see that oxygen right in the middle, and that's important. Again, if I see oxygens and nitrogens, I kind of key in on those, or if I see a carbonyl group, I key in. But I see this oxygen right here, and what's hanging on that oxygen? On one side, over here, it looks like a carbon chain. It looks like it has 2 carbons in it, some hydrogens hanging on it. That's an R group. And on the other side, I also see carbons and hydrogens. Again, that looks like another R group. Those 2 R groups aren't the same, so I'll put a prime on one side. And anything that has an R group connected, 2 R groups connected together by an O, that is a perfect example of an ether. In the final example on this set of families is we have this molecule right here. And notice again, I see a nitrogen sitting right in the middle of that guy, and so that kind of keys me in right there. I see that it's got 3 bonds to it. One has a hydrogen on it, one has this carbon group on it, and one has this carbon group on it. So I have a nitrogen with an H, an R, and another R, and that's a great structure of an amine. So there's an example of an amine and how you would recognize it. Things get a little bit more complex when we started adding in the last 5 groups, and so let's do that now. These are the other 5 groups that you, sort of the basic organic families you would want to know. In aldehyde structure, remember all these are going to have carbonyl groups. An aldehyde structure is going to have some carbonyl group, which on one side of the carbonyl group is an R group, on the other is a hydrogen. So that's an example of an aldehyde, or the basic structure of an aldehyde. A ketone, similar to an aldehyde, except instead of having an hydrogen on one side, it's got another R group on the other side of that carbon. And so aldehydes and ketones are very similar, except notice on the aldehyde structure, it's a hydrogen on one side, and on the ketone structure, it's a second R group on the one side. And I have the hydrogen here on the right. It could as well be on the left. It doesn't matter which side of the carbon that the hydrogen is on. On this example, I just placed it on the right-hand side. Now we start getting, this is where things get a little bit more difficult, and where I start to see where people start to lose what the actual family is. So carboxylic acid, and sorry, I'm going to be stretching out on this page a little bit, so carboxylic acid is going to be a little bit lower than where it's written, at least the name, is this structure. So again, it has that carbonyl group, okay? But notice how it's different from a ketone and an aldehyde. Notice aldehyde, ketone, and carboxylic acid all have an R group on one side of the carbonyl group, so that's not a real good way to distinguish between them. You'll see an R group on one side, but what's on the other side really tells you which one you're staring at. So notice an aldehyde is a hydrogen on one side. In the ketone, it's another R group on the second side. And in a carboxylic acid, it's an OH group or a hydroxyl group on the other side. Now don't get confused, because a lot of people will see that OH and automatically think it's an alcohol, but it's not, because that carbonyl group right here that distinguishes it from an alcohol. An alcohol doesn't have that carbonyl group. An alcohol does have that OH group, but it doesn't have that carbonyl group. So again, just because you see an OH, don't automatically assume it's an alcohol. You gotta see if you can find that carbonyl group that I circled. An ester is sort of like an ether. Those names are hard to distinguish in terms of kind of forgetting which one was which. Ester has an R. It also has that carbonyl group, and then it has another oxygen and an R group. So again, this looks a lot like a carboxylic acid, right? It has, compare this to the carboxylic acid, you have an R group, they both have that carbonyl group. So again, that just, when you see that carbonyl group, you know it's one of these five. An oxygen is next, but in a carboxylic acid, the next atom's a hydroxyl group. In an ester, it's another carbon chain. And so again, notice again, once you see the carbonyl group, you know it's one of these fives. On all of these, you have an R group on one side. On the other side of the carbonyl group is what distinguishes which of the families it is. The final one's an amide. And this one gets confused a lot with amine. They are not the same amine we just went through. In an amide, it's the R group, the carbonyl group, and then on the other side of the carbonyl, now you'll see a nitrogen. So as soon as you see a carbonyl attached to a nitrogen, right here, that's an amide. If you don't see the carbonyl group and it's just the nitrogen, that's an amine, because it doesn't have the carbonyl group, so it's in the other groups of families. So that's really, so if you see the carbonyl and nitrogen, it doesn't really matter what's hanging on it, that's an amide. Okay, so there's your distinguishing, or the 5 different types. So let's go ahead and do a couple of examples of these and practice what we just learned to finish out this video. So here are 4 different structures. So pause the video, determine the family of each of these 4 structures, and then come on back, restart the video, and I will talk through the determining of the family name for each of these structures. So the first one here, again, I see the carbonyl group, and so that puts it into one of 5 possible organic families. So I see that, so I'll draw that as my general structure. On one side of the carbonyl group over here, that I underlined, that's a R group, so I can put an R there. On the other side, I see another R group. It's different, so I'll prime it. And so there's the general structure of a ketone. There's no Y in ketone, it's just ketone. I'm going to change the color of our marker so we can see what I'm describing here. So again, in the second one, I see a carbonyl group there. And then I notice a nitrogen hanging right on that carbonyl. And so right there, when I get the carbonyl attached to the nitrogen and I'll box it, I know that is an amide structure. So I see a carbonyl attached to a nitrogen. The nitrogen will have 3 bonds to it. The carbonyl carbon will have another one. And it doesn't really matter what's hanging on all those. That is a nice picture or structure of an amide molecule. In the third one, I see a carbonyl group right there. On one side, I see an R group. On the other side, I see a hydrogen. This is backwards the way I showed it in the previous slide, but remember doesn't matter which side the R group is on, the carbonyl, or which side the hydrogen's on. This has the structure of a carbonyl group with an R on one side, a hydrogen on the other. So this is an aldehyde. So in all those structures I gave you, when you have the carbonyl group, it doesn't matter which side I put, for instance, like that nitrogen on. It could be on either side. The R group would be on the opposite side. The ketone, doesn't matter which side those 2 R groups are on, as long as there's 2 R groups hanging on that carbonyl carbon, that's what it is. So that's an aldehyde, number 3. And then number 4, here's my carbonyl group right there. So I definitely have a carbonyl group. On one side, I have an R. On the other side, I see an O and an H. And again, this is flipped from the previous side. On the previous slide, I had the R group on the left side and the OH on the right side of this carbonyl carbon. Again, it doesn't matter which side they're written on. It's still the same thing. This is a carboxylic acid. So that's that structure. So going forward from here, what I would do if I was you to help you with this is you can make a flashcard. On one side, put the family name, and probably on the other side of the card, I would draw the structure or the information that kind of tells you which one it is. So something like that, so you can kind of get that information down. I'll be posting more of these types of videos in the future, so please check back if you like these videos, and check back and maybe give you some more information. We'll go deeper into the naming. I do already have some video posted of how to take family names or to name structures. So I think I have a video on alkanes and alkenes, and another one on aldehydes, and another one on ketones, and so forth. So you can practice the actual naming of them. In part, in the naming of them, you have to determine the family name. So this gets you part way there. If you can determine the family name of a molecule, it gets you a lot farther in understanding properties, reactions, naming, drawing, and all that. If you can name that family name. Without being able to do that, you're kind of stuck a little bit, and it's going to be very difficult to name things and draw things if you can't identify the family. So this is really the first step in naming and drawing an organic molecule and understanding their properties and reactions. So hopefully this helped you, and thanks for watching.